I'm Clover, and today we're solving a classic Sudoku by Philip Newman. This is originally posted in GAS on June 11th, 2024, and it's called Classic with six S's, I think, and I'm assuming the reason for that is that the givens in this puzzle are arranged in an S shape. So let's give it a solve. So we have normal Sudoku rules and nothing else. That means the digits in each row, each column, and each outline 3x3 region contain the digits 1 through 9 exactly one time each. So I'm going to start with the three middle regions here in a vertical stack. And first thing to observe, we have all of our low digits here, so we still need 6, 7, 8, and 9. Now 8 and 9 can't go in these two cells, so they must go in these two cells. 9 can't go there, so that's an 8, that's a 9. That leaves us with 6 and 7. There's a 7 in this row already, so that is a 6, that is a 7. In this region, we need 1, 2, 3, and 4 still. 1 and 2 can't go in those cells because they appear in the column, so they go here and here. I need 3 and 4 still. This 3 in row 8 keeps me from placing a 3 elsewhere in row 8, so that's going to fill in that way. Now my remaining digits here, I need a 1 and 9 in the middle column. They'll go there and there because of the 1 and 9 in the rows here. And then I also need a 2 and an 8. So what next? We need to place a 5 in row 2, and it can't go in these cells because of this 5, so I'm going to place it here. We need a 5 in row 8. It can't go in these cells because of this 5, so I'm going to place it over here. I need a 6, 7, 8, and 9 to finish this region with my high digits. I'll eliminate 9 there, and 6 here, and 9 here because of this 9. That places a 9. Doesn't place anything else, but that's enough to go on that we can do some pencil marking up here in the symmetrical region. 1 is ruled out of these 3 cells, so it goes here. That's 2 or 3. These are 2, 3, or 4. So what do we need next? So we need to place a 6 in this row, as well as a 2, 3, and 4. And the thing that stands out to me here is that we have this kind of X-wing-like structure of 6s. You can look at this two ways. You can say either this is like an X-wing of 6s, meaning that we have 6 in one of these cells, we have 6 in one of these cells, so we have accounted for our two 6s that appear in column 7 and column 9. Therefore, we can't have any other 6s in column 7 or 9. The other way to look at it is just we can't have 6s in these cells. We also can't have 6s in these cells. Therefore, 6 must go in one of these two cells. But it can't go there because there's a 6 in row 5 already, so it goes here. We have something similar going on with 4s in the leftmost regions. So we have 4 here or here, 4 here or here. 4 must go in one of these two cells. The 4 in row 5 keeps it from going in row 5, therefore that's a 4. So let's finish off row 4 and row 6. So we still need 4, 5, and 7 here. This cannot be a 4 or a 5, so that's going to be our 7. There's a 4 in column 7, so this is now a 5, and that is a 4. Here I'm going to need a 3, 4, and 5. This can't be a 4 or 5. Or, sorry, not a 3, 4, and 5. 3, 6, and 5. This can't be a 6 or 5, so that's a 3. Then these are 5 and 6. And let's pencil in the remaining digits we have here. Actually, we can observe already that we have 1 and 2 in this column, so 1 and 2 must go in those positions. And our last digit, 7, goes there for the region. That places an 8 down here. And we need to fill in 3 and 4 to finish the column. Here we need to place 3, 8, and 9 in the region. We have 8 and 9 in this column, so that's our 3. And I'll pencil in 8 and 9 here. In this column, we now need 6 and 7. And here we need 4 and 8 to finish this row. Now in this row, we're going to need a 1 and a 9, and those are resolved by digits in the columns above them, and I think that lets us finish everything on the left side of the grid, so we need 2 and 3 there, and that is taken care of. Here we're going to need 2 and 6 to finish this row. We need a 1 and a 9 to finish this row, which resolve. Whoops. And that is going to resolve everything on the right side of the grid. What a beautiful symmetrical classic. I really enjoyed the opening of that in particular. Thank you, Philip. I hope you guys all enjoyed that. The link to solve it yourself is in the description of this video, and I will see you next time.